In the last class, I tried to cover the concepts of the basics of alternative comparison methods, like what could be the method to compare alternatives. And we had looked at the methods which does not consider the time value of money, right? So payback period and the return, average return, and all those methods we had written. And then I had started this present worth analysis method. That's what I was explaining to you, right? So in the present worth analysis, this is the two important things that you need to consider. One is, if it's a revenue generating project, then you also need to consider the do nothing as an option, which is a by default option. If it's only a cost only project, then it's a slightly differently treated, and we saw those kind of examples. And we were discussing about these lifespan scenarios of alternatives. So the most general case is that each alternative has the exact same useful lifespan. So for example, two technology, each is useful for 5 years, and you can compare. But then there are cases where the lifespan of alternatives are different, and we were just exploring how to handle that. And then there are some special cases where the lifespan becomes really long, infinity. So then how does the calculation can be simplified? This particular method again is kind of no longer needed since you have good enough computation power now. Originally, this was designed to make your life simpler on the field. You could make simplistic assumptions to reduce your calculation burden, but essentially concept-wise, I do not agree with the philosophy of this method, but we will still cover it and see what is happening there. Okay. All right. So we were considering this alternative, like case 2, where the alternatives have different service life, right? So first example was this particular example. Let's say A has 10 years of life and B has a 5 year of useful life. So the first method that I told you was to take the LCM of the lives, right? So you will do basically analysis assuming that A is used for 10 years, and you will assume 2 cycles of B 5 years each, right? This is what we were dealing with. Assumption, again, the very critical assumption in this is, first you are assuming that your need is definitely going to be there for the LCM of the 2 lives, right? So at least you are going to need the project for 10 years. That's one assumption. Second assumption is the project B or the alternative B, the second cycle of alternative B is exactly same as the first cycle of alternative B, which again is not a good assumption. If you are dealing with long time horizons, you cannot expect the cost of the technology to remain same in 5 years compared to now. Their performance might even go down. That's also another problem. But that's an assumption that you are able to get exactly the same cost cash flow 5 years later or 10 years later for the low cycle alternative, right? So with that, I started this example. I need to make a road which type A and type B. So cost of the new road for type A is 4 lakh rupees. For type B, it's 1 lakh rupees. Annual maintenance for type A is 20,000, while for type B is 40,000. So this makes sense. Initial high cost but low maintenance alternative compared to low initial cost but high maintenance cost alternative. The estimated life for product A, because it's expected to be good, is 10 years, but it is only 5 years for type B. The salvage value, this is the value which I also had given you example in the assignment. It's essentially the value at the end of the service life that you will get back, right? Could be because of material recovery, could be because of other things. Maybe in like type A road, there is some steel bars, let's say you have put, and that you, after you recover, sell, you are actually able to recover the steel bar and sell it some price value, right? Could be other forms. Salvage value could come from multiple reasons. So that becomes 50,000. But for type B, you are not expecting any money at the end of the 5 year. The interest rate for both, or the, in this case, MARR, which is the minimum acceptable rate of return, is essentially 6%. So for type A, the LCM in this case is what? 10 years. So for project A, you just need to consider 1 cycle. For project B, you need to consider 2 cycles, right? So for type A, the cost of new is minus 4 lakh. The annual maintenance of 20,000, you convert it to the present worth using the P by A factor. That comes out to be this value. And then the salvage value, which is occurring at the end of 10 year. It's a positive value because you are getting it back. that converted using P by F formula comes out to be 27,920 rupees, right? So your total net present worth for type A road is this particular value. This is where we left, I think I had covered this example. Now for type B, the first application, basically you are dealing with 2 cycles of type B. The first application, the cost is minus 1 lakh. Second application, the cost is, because it's occurring at the end of year 5, right? So this is minus 1 lakh rupee. Again in the second cycle, another 1 lakh rupee will be required for cost, right? Because you need to recreate. So that value converted to P by F, 6% 5, that comes out to be this value. Annual maintenance doesn't change because A value is same throughout in all the cycles. So you are distributing the 40,000 P by A, 6% for 10 years. Okay, why did this 10 years come? Because in your entire series, you have actually 10 equal cash flows of A amount. So you are estimating the present worth of that A series, and that's the value that it comes out. Right? Make sense? Any other thing that we are missing? So you are saying that instead of this, the series should be like this. Is it? Why? Yeah, so it's a good confusion to have, but imagine that for 1 year you will not be able to provide any service. So idea is that maybe your road is already between the year 4 and 5, your road is already on the downward trend, performance of it is already on the downward trend, such that at the end of year 5 it will become 0. If you want to continue the operations, you need to start putting money to keep it on the same level. So in year 5, while your road is degrading, you are also putting money to rebuild it. And by the end of period convention, that comes at the end of year 5, not at the 1 year gap of 5 and 6. Because otherwise there is a service disruption. In this 1 year, there is no road service. So that is not a good alternative. Still doubt? Yeah, so 1 lakh is being used for reconstruction. So reconstruction in the first, you are assuming that it happened at year 0. Of course, there might have been some time before the reconstruction started, even in the first alternative. But by the end of year convention, you are saying that at the end of year 0, you require minus 1 lakh. The same thing is occurring in the second case also, right? Essentially, you are superimposing the 2 series. There is no gap in the cash flow series, right? Make sense? So in general, the present worth of this alternative is coming out to be 4,69,130 rupees. Okay. So in this case, it suggests that type B is less expensive, right? So it seems that the cheaper alternative wins here. The initial low cost, despite the high maintenance cost, you are still able to favor that particular alternative. There could be questions like, what should be the maximum annual maintenance amount that you can afford so that your type B alternative is always favorable compared to type 1, right? For example, if the annual maintenance of type B will increase to, let's say, 80,000, this present worth will be much huge perhaps compared to type A, such that type A becomes more favorable, right? So those kind of comparisons you can make, those kind of analysis you can make, because in real world, none of these values are as deterministic. You will never be able to 100% say that this year only 40,000 rupees will be required. Could be 60,000. So in that case, are you still profitable or not? That's the concept of risk we will be dealing later. Idea is clear? With me so far? Alright. Then there are 2 other methods also how to deal with alternatives with different service lives. So method 2 is you shorten the comparison period to the expected lifespan of the shorter alternative. So let's say A was of 10 years, B was of 5 years. So instead of taking the LCM, you actually bring A to 5 years. How? Basically, in this case, you need to attribute a salvage value to the longer lived alternative. So what I mean is, originally, let's say my series was whatever this n is coming out to be. I want to convert it to something like and a big salvage value. So I'm assuming that all these differences of years that I'm not using the road, basically I'm selling my road in a slightly better condition 3-4 years ago compared to 3-4 years later. So the amount that I get as a salvage value is slightly higher compared to what it would be for 5 years later, right? So that's the idea. So I give you an additional value of salvage value, and now I've disregarded all other cash flows of the original type A. I have converted that to only here, the smaller time period, and I've given you some salvage value which is equivalent to whatever the remaining service life for type A alternative was, right? Again, sounds very easy in principle, but in real world very difficult, because again, once again you have a problem of determining the salvage value to the correct extent possible and all. We will deal with concept of salvage value later, but essentially it sounds theoretically very easy. It's not very easy to do in real world, right? So this method is usually not preferred, but at the same time it exists in case your analysis demands for you to do. Okay. Another possibility is something called a planning horizon. What happens is, let's say as a company, you are invested in, your demand is only for next 2 years. You are expecting that in next 2 years the technology will completely change. So none of the current alternative will be useful for me. So I don't want any analysis more than 2 years, because after 2 years I have to take a completely different set of alternatives into account and totally a new analysis perhaps. So I only want right now, I only want something which can fulfill my requirement only for 2 years. So that's my planning horizon. Now it could be that in market nothing exists which supplies only for 2 years. Could be market could be having that even if you buy one versus buy two, both of them are having 5 years or 6 years of service life, and accordingly they have some cash flow, but you are not interested in that. So your interest as a person or as a company takes much more precedence. You only take the analysis till the planning horizon, and you completely disregard the cash flow series after the planning horizon. So for example, if a particular alternative has, let's say it will make money after some n years, but my planning horizon is only here. So I disregard whatever happens in this part of the cash flow series. I only take into account the cash flow series before my planning horizon and then compare the alternatives. Okay? Makes sense? In this case, I am not even assigning any salvage value. I am giving you the planning horizon. Salvage value could be coming if at the end of year 2 I define that I will sell this and I am expecting some money to come out as a salvage value. You can assign that, nobody is stopping you, but essentially you are only considering the cash value till the planning horizon. Okay, so all the related cash flows beyond the planning horizons are ignored, and hence this method does not capture the full useful life of an alternative. So no matter which method you choose, they have some or the other limitation. The first method has a limitation that it assumes the repeatability of the cash flow series, and it also assumes that you will require the alternative for the LCMs of the two lives. The second method has difficulty in terms of estimating the salvage value. The third does not even consider the long effect. It just completely ignores whatever is happening beyond a long service life, right? So every method has a difficulty depending upon, or not with difficulty, limitations. You also have to select the method what suits your needs the best. Okay, let's look at an example. Actually, and depending upon your method, your answer to the alternative might change also, and we'll look that part into here, because there is no absolute answer. It all depends on which method of selection you are using to compare the alternatives also. Okay, let's have a look here. So there is a national home builders which plan to produce a new cut and finish equipment Two manufacturers offered the estimates as below. So vendor A and vendor B. First cost is $15,000 versus $18,000. Annual operation and maintenance cost, which is dollar per year, is 3,500 and 3,100 for the two. The salvage value is 1,000 and 2,000. Again, it's dollar. And the life in years is 6 years and 9 years. Right? Making sense? So determine which vendor is to be selected on the basis of a present worth comparison if MARR is 15% per year. When I am not giving you any information, all I am saying is a present worth comparison. By default, we go to the LCM side. Okay? Only if I am mentioning anything about the planning horizon or I am mentioning anything about the salvage value and a fixed time period, then only you need to do. By default, present worth analysis means LCMs of two unequal lives. Okay? So, let's do this first method. This is the cash flow series. What is happening on A is actually basically what's the LCM of the two? 6 and 9? 18, right? So, there will be 3 cycles of alternative A and 2 cycles of alternative B. So, the cash flow series, the full cash flow series of alternative A for the 18 years is shown here, and the full cash flow series for alternative B for the 18 years is shown below, right? 15,000 at the year 0. This is the annual whatever the maintenance amount. $1,000 is the salvage value that you are getting at the end of year 6. That comes here. You are again investing $15,000, converting the cycle and so on. Making sense? Alternative B, 18,000 at the beginning. This whatever this A amount is given to be there. $2,000 is your salvage value, comes here. Again an $18,000 investment at the end of year 9 and the cycle continues. Making sense? Give me the present worth of both. What happens to this 15,000? Remains same or some factor? Remains same. What happened to this cash flow? $14,000 or 14,000 minus this 3,500 or addition of that? 14,000? How many people are saying 14,000? Why? Yes, if you don't take this cash flow, you can apply the A series for the entire 18 years. So it's a single formula, you are shortening your calculation. Otherwise, you have to bring everything into multiple series. So the net effect is 15,000 minus 1,000, which is the 14,000. Which formula? P by F or F by P? P by F. Bring to 6 years in front. Similarly, 14,000 P by F, 12 years. Here, there is no 15,000, only 1,000, which comes to P by F, 18 years. Making sense? So far with me or no? What is the rate? 15%. This is what? 12 years. This is 1,000. P by F, 15%, 18 years. This is 14,000, P by F, 15%, 6 years. Then what's the A series? P by A, 15% for 18 years multiplied by 3,500. Okay, sum of this, what is it coming? What is P by F 15% 6? .4323, okay. P by F 15% 12, okay, and 15% 18, 0.0808. And what is P by A 15% 18? Is the answer matching? So all your terms are there. Initial 15,000, 15,000 at the end of year 6, the 1,000 salvage value at the end of year 6, 15,000 at the end of 12, 1,000 value at the end of 12, 1,000 at the end of 18, and 3,500 distributed over 18. Right? All the terms are there. What's the answer? Matching or not? How many not matching? Genuinely tell me. 0.36. Okay. So then give me the answer for this second series. One option is 40,000 something something. So correct answer is 41,384. What are you missing? First U1 took as a 16,000. Huh? Yeah, not correct. See, again, I am re-emphasizing. Nothing rocket science in this course. All these formulas, transformations you know. But you see the variety of answers you get. It's all about practicing. Don't take this lightly. You will not score good in marks if you just take it. These small mistakes, your 10 marks is gone. Essentially, if it's a 10-mark question. Or at least half of it is gone. Right? So do practice, do the assignments on your own, find practice problems. It's important to establish your flow of information where you are calculating and everything. Just be in that rhythm. Okay? So which option to choose? Option B or option A? According to this, option B. Why not do nothing? Why are you losing money? No revenue, cost only. Exactly. So that's the reason of why not choosing the do nothing, because this is a cost only problem. Never ever I have mentioned that this is a cost only problem or no revenue problem, but you have to make that judgment what is being talked in the context, right? So in this case, you choose option B because the less negative value of PW. So the absolute amount is higher in that, and therefore option B is better. Now, suppose I give you that a study period, or in this case, the planning horizon is 5 years and the salvage values are not expected to change. Which vendor should be selected? Can you draw the cash flow series? Can you help me draw this cash flow series of vendor A? What is the initial amount? 15,000. How many payments of A? This is 3,500. Should there be more? You are dealing with only planning horizon of 5 years, right? What is the salvage value? 1,000. Is it? Where does it occur? 6th year. Salvage value should be coming at 6th year. I just like this course. I should teach this. There's so many options coming up. So he says salvage value should be at the end of 6th year. So then salvage value should not be taken into account. But it has to come at 6th year only. How many of you think salvage value should be in 5th year? So the majority prevails. Essentially, yes. So see, always don't confuse on those boundary conditions of what if I sell, I am not able to sell on the same period I am using and all. That's the assumption you are making here. Okay. You are like, oh, but I am using the machine till 31st December 12 p.m. and I am only selling it on 12:01, so where should that money go and all? Those assumptions you can ignore. Accountants do not know so much mathematics. They don't care about the timing. They want their life simple, and that's how the conventions are made. Okay. So this end of year convention always confuses. Don't go engineering on that. Although it is an engineering economics course, don't go too much about those details. Okay. Try to read. So this is the $1,000 at the end. You are assuming that everything you are able to do only in this. It doesn't make sense. If this asset is unused for 1 year, it doesn't make sense for you, right? Your company may not exist after 1 year. So in this case, the value is coming out to be 26,236, right? 15,000 for this, 1,000 is the salvage value, and 3,500 for 5 years distributed as A. You are getting this value. Option B, if you do, it is coming out to be minus 27,000. So which will you choose? Vendor A. Answer changed. In the previous method, you were choosing option B. Now you are choosing option A. Still doing annual present worth calculation. Still the answer is different because your time calculation or everything changed. So there's no absolute winner in any of these alternatives. A very significant part of it is also dependent on what you want from your alternatives, and therefore your methods have to reflect the comparison criteria. Okay? So far with me, everyone? Any doubts? Alright. So there's a very special case where assume that you have infinite life projects. Typically infrastructures, what happens is they are like almost 30 years, 40 years, 50 years kind of service life. In that, there can be calculation can be made slightly simpler. That's the whole idea. Again, the kind of assumption this method makes to make the calculation simpler, I do not agree with them. I don't know what is the rationale behind them. In one book, it is written like that. Therefore, I am presenting you here, but I don't understand the reasoning. So, better, because you are not limited in computation power, still go with the normal methods. Do not use this method unless you really need to. Okay. But still, let me give you what exactly this is. So, there is a convention. This method uses something called a capitalized cost, and which we denote using capital CC. Okay. So this is the present worth of a project that has a very long life, or when the planning horizon is very long or typically infinite. In that case, the present worth is, instead of PW, it's actually represented using capitalized cost. Okay. So, and the philosophy of how to determine this particular method is from one of the examples that we saw previously. So what was happening in this particular example, we were paying, you remember this cash flow series I had told you in lecture 1. What we were doing is, we borrowed some money, let's say 5,000 rupees. Each year we were just paying the interest back, right? So the capital amount did not change. The original principal amount did not change throughout. So that's the kind of concept it borrows. So you can actually practically extend this series to infinite. Your principal amount will always remain 5,000, right? And any year, the interest that you are paying is essentially P into the I, small I rate, right? So this is a simplistic way to understand. Of course, you could derive it mathematically also. I'm just giving you a very simplistic way to understand and memorize this formula perhaps. So what is happening in this case, as long as you are paying P into I as an interest every year, the useful life of your asset is practically infinite, because your capital is still the same. It's not decreasing, you're not repaying the loan. It's basically useful throughout your entire as per the time goes. So this is the concept that they borrow. So if A is equals to Pi, the investment can continue for infinity, right? So this is precisely the formula that they use to calculate the capital cost also. So what they do, they say that P is equals to the capitalized cost CC, and then if you can want to estimate the essentially if you want to estimate the capitalized cost, which is the present worth, you need to estimate the annual worth of that long time series, which will take an example, and simply divide it by I, which is the interest rate. This formula you can also derive by A by P formula or whatever. Limit remains same, limit n tends to infinity. You will see that the same representation will come. This simplistic relationship A is equals to Pi holds true when n tends to infinity, right? Or n is a very large. Why does it happen? Because if your n is like, let's say 50, this amount A, the effect on the present worth of this will be very, very small. This is like what? A upon 1 plus I to the power 50. Even if your I is very small, the 1 plus I to the power 50 becomes too large, that this stops contributing to your present worth significantly. The error will not be too high. So therefore, this kind of method works, right? N tends to infinity. You can also derive this formula if you are interested. So that's the definition of capitalized cost. So if you want to estimate the capitalized cost, what you need to do is you need to estimate the annual worth, divide by I, only in cases where this assumption of long service life holds true. Now, there is no practical definition of what is long service life. At what N can you consider it long service life? Again, it is a matter of convenience. So therefore, avoid this method if you can. If I have specifically asked you to make your life miserable, you have to use it. But otherwise, in your regular methods, do not use this method unless otherwise stated. Okay? So, this is the formula that you use. So, when I ask you capitalized cost, you can estimate the annual worth and divide by I and get the answer. And then you can choose the alternative is highest capitalized cost or lowest capitalized cost depending upon what kind of analysis you are doing. Alright. And then this book also gives, the same book that I have been following so far, also gives some examples of how to make the cash flow series for them. And this is precisely where I do not agree with them. So what do they say? That in order to see, ultimately you need to estimate the A value. For any cash flow series, you need to estimate the equivalent A value. That's the basic method. So for doing that, the limitation is that you cannot draw cash flow series for 50 years or 70 years. That's what you cannot do. That's the point where they have made simplified assumption to just draw the cash flow series only, right? And this is precisely which I don't agree. And let me just give you an example for the sake of completion. So they say that draw a CFD, which is a cash flow diagram, showing all non-recurring cash flows which are occurring just once and there are no periodicity for them, and at least 2 cycles of all the recurring cash flows. So let's say there is some cash flow pattern, at least 2 cycles of that you should put. So typically if a project has 30 years life cycle, 2 cycles of that would still lead you to a 60 years cash flow series, which they thought it's reasonable for us to handle, and perhaps later you just make your life much more complicated without too much effect on the error part of it, right? So that's one idea. And then you have to find the present worth of all the non-recurring amount and their CC value. Let me just give you an illustrative example. We will solve the detailed example later. Let's say some pattern of cycle is there. So these are the recurring payments. There is a pattern of those recurring payments that I have given to you. So I have plotted 2 cycles of that recurring payments. And in between there could be some large maintenance activity required. So I plotted those non-recurring values. And then what I am asking you is convert all these cash flow series into an equivalent A value, right? So for non-recurring, the answer remains simple. You first estimate the present worth. So that is a simple formula of F by P transformation. And this kind of series is you can handle through your A by P transformations or P by A transformations, whatever, right? So the idea is first you have to find the present worth of the non-recurring amounts. That is step 2. Then you find A values through one life cycle of all recurring amount. Add this to all uniform amounts occurring in year 1 to infinity. This is a total annual worth factor, which is essentially all the recurring kind of a thing. You convert them to an effective A value. That's what this step is asking. Now this effective A value you convert again to the present worth, because your capitalized cost is a present worth formula. It's not an annual worth formula. This is a long series. So converting this is a simpler, not by your conventional method, only using the AW by I formula, because you are assuming that this is a really long series. So you don't need to convert using the formulas. So in order to obtain the present worth of this step 3, you divide the step 3 answer by I to get its present worth. Then you add the answer of present worth obtained in step 2 and step 4 to get the total capitalized cost. Okay? Unnecessary complicated method. It has nothing to do with the science of it, just one specific type of transformation. This what people thought that this is a good method to do. But is it clear what we are doing? Basically, you ultimately capitalize cost is a present worth method. It's not an annual worth method. For non-recurring transaction, you can simply convert into a present worth using P by F formula. All the recurring transactions, you can first convert into an equivalent AW, the annual worth, the equal A payment amount series. Transfer that to present worth, dividing simply by I, not by A by P formula essentially. That's what the method is. And then you add the answer to get the total annual, total present worth, and that is what calling as capitalized cost. Okay? Making sense? To me, it doesn't make sense. But if you are making sense for it, that's good. We'll look at one example, but let me start introducing one important aspect of the whole thing, which is I've been using the term called annual worth analysis. That's also one of the ideas to compare the alternatives, and let me start going towards that. So we are finishing present worth based analysis. So far with me? Only the last part is a bit tricky, which will get clarified in a question later. Okay? Alright. So let's move on to this analysis called annual worth analysis method. Idea is essentially same, but sometimes the present worth is not intuitive enough. For example, you say present worth of $500 versus $5 million, which is better in different alternatives when you're talking about, or different investors you're talking about. The absolute value of the present worth may not be relevant, right? If I'm a really big investor, a present worth of 500 is not significant for me. A present worth of 5 million may be too much if I'm just a small investor, right? So sometimes the absolute value of the present worth is not an easy measure for a lot of people to deal with. Therefore, a simplistic method is this annual worth, which is like on an average in a year, how much money will I make? This investment, every year, how much money it will make to me. So that's an intuitive, little bit more intuitive way for business people to make their judgments. And therefore, this method has also very interesting aspects. It has also some advantages. I will also explain that slightly. Right? So what you do is, earlier you were comparing all the cash flow series, you were converting them to a present worth and comparing. Now instead of that, you convert your entire cash flow series into an equivalent A amount, and then you compare that. Okay, that's the whole idea. So compare competing alternative proposals by reducing all cash flows involved in each proposal to an equivalent series of equal periodic payments. So instead of P, you are now estimating an equivalent A. The higher the equivalent A, the better is the alternative, and all other things that we saw still applicable. Right? So this is particularly useful for making presentations to people with limited background of time value of money. Because in present worth, you are saying, oh, computing periods are N, discounting cash flow is happening for 50 years, 30 years, blah, blah. I am not that literate. Tell me, if I invest, give you 1,000 rupees, every year, how much money will you give me back? That's the kind of simplistic idea to estimate this particular thing. Because it doesn't matter what the cash flow series and everything is, it's a very simple way to represent the answer. Right? There is one simpler, the method makes your life slightly simpler by, let me give you an example here. So, in the previous method, the complication of unequal life, right? We needed to take LCM and so. That problem is you can get rid of that problem here. You don't need to do the analysis for multiple cycles of the same alternative. If you estimate the A value just for one cycle, you can directly compare the results even if they are unequal lives. Okay, what does it mean is, let's say you have alternative A for 5 years, B for some random 7 years. You don't need to take 35 years as an LCM and then do the analysis of A for 7 times, B for 5 times and so on and so forth. You simply estimate the equivalent A value for just one series for alternative A. Similarly, you equivalent A value for just one period for alternative B, and you can directly make the comparison. You don't need to do the LCM and those kind of calculation. Why is a food for thought for you? Tomorrow we'll start discussions from here. Okay, but essentially you don't need to take LCM. That's the only benefit this particular method also offers. Okay.